Welcome to Engadget Tomorrow. I'm Imran Sheikh, and this is where you get to hear about tomorrow today. We've had a few recent episodes about what's in space and how we get to it, from volcano-covered planets to space tourism. But there's also another question. How do we get things from space to us? Let's start with data. Earlier this year, AST SpaceMobile, with the help of AT&T, managed to connect an off-the-shelf Samsung Galaxy S22 to a satellite in low Earth orbit to complete a two-way voice call. The announcement marked a major milestone for satellite-based cellular communication. Now the company says it's one step closer to bringing the technology to consumers. On Wednesday, AST shared it recently completed multiple tests in Hawaii, where its engineers saw download speeds of 10 megabits per second from the company's Blue Walker 3 satellite to unmodified phones on the ground. Successfully reaching double-digit download speeds during satellite to smartphone testing takes us one step closer to ensuring people across the United States will be able to stay connected no matter their location, said Chris Sambar, AT&T network head. As a next step, AST hopes to connect a phone to BW3 over a 5G signal. A SpaceX Falcon 9 carried the prototype satellite to low Earth orbit in September. At 693 square feet in size, BW3 features the largest antenna of any commercial satellite to date and is easily one of the brightest objects in the night sky, making it difficult for astronomers to carry out their research. AT&T is one of a few U.S. carriers looking to use satellites to service underserved rural communities. In 2021, Verizon partnered with Amazon to use the company's Project Kuiper satellite network for wireless access. More recently, T-Mobile said it would work with SpaceX to test Starlink-capable devices. Like AT&T, the carrier has said existing phones should work with its satellite offering. Data is one thing, but power would be a whole other. The idea of solar energy being transmitted from space is not a new one. In 1968, a NASA engineer named Peter Glaser produced the first concept design for a solar-powered satellite. But only now, 55 years later, it appears scientists have actually carried out a successful experiment. A team of researchers from Caltech announced earlier this month that their space-borne prototype, called the Space Solar Power Demonstrator, or SSPD-1, had collected sunlight, converted it into electricity, and beamed it to microwave receivers installed on a rooftop on Caltech's Pasadena campus. The experiment also proves that the setup, which launched on January 3rd, is capable of surviving the trip to space, along with the harsh environment of space itself. The experiment, known in full as Microwave Array for Power Transfer Low Orbit Experiment, or MAPLE for short, is one of 3 research projects being carried out aboard the SSPD-1. The effort involved 2 separate receiver arrays and lightweight microwave transmitters with custom chips, according to Caltech. In its press release, the team added that the transmission setup was designed to minimize the amount of fuel needed to send them to space, and that the design also needed to be flexible enough so that the transmitters could be folded up onto a rocket. Space-based solar power has long been something of a holy grail in the scientific community. Although expensive in its current form, the technology carries the promise of potentially unlimited renewable energy, with solar panels in space able to collect sunlight regardless of the time of day. The use of microwaves to transmit power would also mean that cloud cover wouldn't pose an interference. Caltech's Space Solar Power Project, SSSP, is hardly the only team that has been attempting to make space-based solar power a reality. Late last month, a few days before Caltech's announcement, Japan's space agency, JAXA, announced a public-private partnership that aims to send solar power from space by 2025. The leader of that project, a Kyoto University professor, has been working on space-based solar power since 2009. Japan also had a breakthrough of its own nearly a decade ago in 2015, when JAXA scientists transmitted 1.8 kilowatts of power, about enough energy to power an electric kettle, more than 50 meters to a wireless receiver. The Space Solar Power Project was founded back in 2011. In addition to MAPLE, the SSPD-1 is being used to assess what types of cells are the most effective in surviving the conditions of space. The third experiment is known as DULCE, a much easier way to say deployable on-orbit ultralight composite experiment. It's a structure measuring 6 by 6 feet that demonstrates the architecture, packaging scheme, and deployment mechanisms of the modular spacecraft, according to Caltech. It has not yet been deployed. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributors Igor Bonifacek and Dana Wallman, and was produced by Spoken Layer. I'm Imran Sheikh, and we'll talk more tomorrow.
Spoken Layer.